So hello guys, welcome to our channel. Uh, so today is 1st of November 2021 and today we will discuss today's Leetcode challenge. This is the first day of November, so we are starting this challenge and we will continue this for the next like 30 days and complete this and try to complete entire series of these questions and win a badge. So the title of this question is surrounded regions. This is a medium rated question and you can see it's like fairly famous question. There are about 4,000 likes, so you can conclude that it's a good level question and very famous as well. More number of people has given his like, which surely means it's a very good question. So what the question states, we will first go through the question, then we will understand some test cases and then we will jump to the code. So given a m cross n matrix board containing x and o's, capture all region that is 4 directionally surrounded by x. A region is captured by flipping all o's into x's by surrounded region. So this question is like very basic, like not basic in terms of understanding. This very easy question. You might have understood that this will be going some like a board of some dimension and it will contain either x, like each cell of this board will either contain x and o and so we have to capture all the o's. Like a particular region is captured if like we can capture a region by flipping the o to x, and if it is x then it is already captured, so we need not to capture this. So let's go through this. The question is like after reading this you will not be able to write the question because there is some twist. You will have to go through this particular test case to understand the question better. You can see, like if you directly read the question and go through this like you will, like if you have read this question and you only think you might have came in your mind is run a loop of o. First loop will traverse over the rows and will nest that loop with uh, uh, a for loop. We will iterate over the rows and then we will check whether it is like o or x. If it's so, we will do it an x, but this is not how the problem. According to that intuition, the solution of this problem must not contain an o here. So there is some twist. We will go through this test case and we will understand what that is. So this is the input matrix. We have nothing to do with this, and this is the output. So these are just representation in terms of the characters. So explanation of this test case: surrounded region should be not on the border, which means that any o on the border of the board is not are not flipped to x. Any o that is not on the border and is not in the contact of o on the border will be flipped by x to x. Two cells are connected if they are adjacent cells connecting horizontally or vertically. So what did you understood, that if a o is on the border, then we cannot capture it. It's not we cannot capture it. And also if a particular cell, like here there is no cell like that, but if say there is a cell just adjacent to it, like in these three blocks also, like they have cleared the definition of being an adjacent. Cell is adjacent to another cell if it is connected horizontally, like either like this direction or this direction, though there is no diagonal relation between a cell and their surrounding cell. So there is only vertical or either horizontal or vertical relation between the cells. So if a cell is connected to a particular cell, so if like a particular uncaptured area cannot be captured if it is on the boundary. So see, this 0 is on the boundary, so in the in the test, like in the resultant, it's still over, like we cannot capture it. but internal O's, as they are not in boundary and neither they are in contact of either any of the boundary cell. So this gives us an this gives us that these O's will can be captured. So this is a test case, and that and also that this definition continues, like if there is suppose instead of x it was a 0, so due as this cannot be captured, this will not be able to captured, and as this cannot be captured, these and these cannot also be captured, and if these two cannot be captured, this cannot be captured. So entire resultant uh, what yes, the resultant will also have us like an empty x, like resultant will be the same as that of the input. So this property continues if a particular cell, like if a cell which is a like a contender for being captured, if that cell is surrounding by a cell which cannot be captured, that cell cannot also be captured. So this is that case. So we have to take care of this as well. So this is the question, and I will appreciate if you all pause the video now and give it a shot, and if you all solve, if any one of you like you can definitely, but if you didn't, if you all if anyone if all if you all solved it, then well and good. If you didn't, I will let you know the solution. So yeah, give it a shot. So I hope you all tried this question. So now like let's slowly steadily build the approach how to solve this problem. So let's consider a cell, like not in this particular test case, consider a general cell. Like in that particular cell, a board can be like a particular O on the board can be flipped. It's not a what do you say, if it's not on the border, or first of all let's consider just border. If that cell is not on the border, we can definitely flip it. So it's an easy task, easy go question if there was not a twist of this O at the border. So we can easily flip the O's which are not on the border of the matrix or like this board. But all the questions like these so one thing you might be thinking, that problem, like the problem became tough just because we are considering the diagonal. So it will be easier for us to solve this question if we think in terms of like if we eliminate the if we first of all eliminate the cells which cannot be like flipped with O's, like not entire board, the O's which cannot be flipped, and then we again if then we try on changing the line, try on capturing that, it will be very easy for us. So we will take this approach only. What we will do, we will start off with like in any order from this top row, then last column, bottom row, and this, like you need not to follow this spiral path, you can do in any way, but I'm just like it's very common to uh, pass like traverse a matrix in a spiral way, so that's why I used it. You can traverse in any way. We will go through the boundary of the we will go through the boundary of the this matrix, and then we will select one by one the, like we will, if we got any 0 in on the boundary, then we will be for sure that we cannot mark this as we cannot capture this. So then and also there is a condition that all its surrounding uh, cannot also be like cannot be marked as present. So you can see like if this particular notice cannot be marked as present, cannot be captured, then its surrounding can also not be captured. So you can see that recursive relation. So what we will do, we will consider a cell and then we will check its all the childrens. If any of them is like 0, then we will also mark that this particular cell cannot be captured, and then the pattern continues. If we will follow this pattern, uh, we will like get to know which cells cannot be marked as like cannot be captured. So by this way we will able to solve this problem. This is the basic approach. This is very pseudo like a basic idea behind it. Now we will see how to actually code this idea. So this is my solution. These are like this will store our number of rows, sorry, number of columns. This is a member functions of this solution class that I have created. This is a pointer to my the board that I will get through input and input. This is the number of rows, number of rows, and m is the number of columns. So we have to write our function like this is the main function that the system like the online judge will call. So we have to basically start from here. So we have stored the nnm as the number of like as num is the vector of vector, so num of vector dot size will be number of rows, and m will be this like board of 0 will be first. If you anyone of you don't know, the board of 0 will be the first row. Number of members of these row will be the number of columns. So that's why I'm storing columns. And also like you can directly like this is a edge case. Like if you consider a 2 cross 2 matrix, 1 cross 1 matrix, then every border will each and every cell will be on the edge. So it's impossible to flip any of the cells. So we will directly return in that case. Otherwise what we will do, this is our member pointer that we have declared here. So this we will store the address of our board in it, and then this is the we are traversing over the rows like rows. Then we are just checking if a particular node is O, then we are calling our DFS function. You can see these 4 calls that we can see. Let's go to our DFS function. DFS function is here. Then as this, and also like so at these cells are cannot be what you can say cannot be captured. So that's why we are flagging, like we are flagging that particular variety of cells that these cannot be captured. And then at the end when we will return our function, we will again reassign these leftover cells as O, so that we didn't get any wrong answer. We will able to, we are just flagging that cell with R, and also we are checking if R is greater than 0. Like these are some standards you can go through, it's very easy. You just checking whether we are not getting out of the board, like row is greater than 0, then we are decreasing, less greater than 0, and these are just like boundary condition that we are checking, that so that we didn't like as for a particular cell we are calling on both for the or 4 sides. So it might be possible that in a, like if we are here, then we might make a call here which is an invalid cell. So these cases are just checking that and making call upon its if it reachable, then we are calling on it. Yeah, so this is how the DFS will work. And now here we are just again going through the our this grid, and if a particular cell is O, then we are marking it as an X. If is R, that we have flagged initially, that if a cell is R, we are then again marking it 0. So this, yeah, so this is how the question will be done. And thank you, we are done for the day.